All right, Dawn, let's go ahead and kick it off. So we're going to be answering your questions. Feel free to go ahead and ask in question and answers, and we'll call out after Dawn's presentation. So thanks for joining us, and we hope you enjoy this new monthly series that we're going to be doing.
Yeah, so we thought rather than have me talk about what I thought I should talk about, we'll just ask you guys, what would you guys like to know? And so we sent out an email here a couple of weeks ago, and we got a whole bunch of questions in. Thank you very much. So we're going to shoot through those and see what we got. So one of the questions is not in any particular order, but how do I overcome an installation where the transmitter may be 10 or 15 feet from the receiving antenna and as far away as 100 feet? So there's not a single answer to this. You certainly can be too close to an antenna. And if the antenna has enough gain and you have enough power in your transmitter, in other words, 50 milliwatt transmitters have 50 milliwatts, and some of the new digital stuff only has 10, 3, or even 1 milliwatt, and it works great. But obviously, the stronger it is, you really can think about antennas kind of the way you think about microphones. Obviously, if you get too close to a microphone, you scream really loud into it, you get distortion. And so that's what happens in your receiver. You're going to overload the front end, and all kinds of bad things are going to happen. And as you get farther and farther away, what happens is the total voltage drops. So it becomes a very, very faint signal. But typically, your dynamic range doesn't change. So if you've seen any of our other webinars, the single most important point about making a wireless microphone work is keeping that dynamic range, that signal to noise or carrier to noise ratio strong. You have to keep your signal at least 20 dB away from your noise. So if your noise is more or less evenly spread out, now if you move 100 feet and you get next to some horrible interference generator, well, it's going to pick that up more. But normally it kind of spreads. Interferences more or less equal everywhere, typically. So what's going to happen as you move farther away, as you move the easiest, if we take 12 and a half feet, because it's easier to do the math and you can follow. So every time you double the distance from your antenna, you cut the power 6 dB. In other words, you're at 1/4 the power. So from 12 and a half to 25, you're going to lose 6. And from 25 to 50, you're going to lose 6. And from 50 to 100, you're going to lose 6. So you're losing 18 dB of the voltage that's going into your radio. But the dynamic range should stay the same. So, there's going to be a point. Antennas work forever, right? Antennas work at thousands of miles, tens of thousands, millions of miles, but the level keeps dropping down, right? So it's not that the antenna stops working, it's that the level gets lower. And when you get to the point where you're far enough away that the level, because the noise is going to drop too, so your dynamic range is going to stay more or less the same, but your voltage is going to drop. And I would expect for most people, it would still be good at 100 feet. So what you kind of have to watch for is overpowering the receivers at 15 feet. So that would be the first place I'd look and make sure that you're not overloading the front end. In some cases, so if you are overloading the front end, if you have a terrifically powerful antenna, if you have like one of our helical antennas that has 10 dB of gain and you're trying to work 10 feet from it, it's amplifying your signal, before it ever gets to the receiver. That's going to be a very, very hot, very, very hot signal. And, that might overload the front end. So I'm going all over the place here. One of the things you could do would be to turn your antenna slightly off axis, assuming it's a directional antenna, right? So we think about antennas as having a pattern. go back to microphones. Basically, cardioid microphones and omnidirectional microphones. Pretty much everybody understands those. But when you get really close to an antenna, just like when you get really close to a microphone, the pattern doesn't really hold up anymore because you're so close to it. So one of the things you might do if you had to be 10 feet away from your antenna is don't point it straight at your stage. Point it somewhere else. Point it to the back of your stage, point it out to your audience, something like that. If that were the case, so if the case where I had to be 10 to 15 feet on my stage, but I've been to churches where the minister likes to get out and walk all the way to the back of the hall. In that case, if you had the antenna on the stage and you sort of pointed it towards the back of the hall, but you were still very close to it on the stage, that would work. But ultimately, you are going to have to protect overloading the input of your radio. So that you must do, because if you don't do that, it's not going to matter about the 100-foot thing, because you're gonna wipe it out in the meantime all the rest of the time. So, and if it won't work out to 100 feet because you have a really high noise level or something, then you're going to have to install a second antenna to capture that 100-foot away thing. That's also a possibility. But I would expect most people in most of what I call common situations. So if you're on a stage, a very tiny stage, and then you have to walk far out into the audience, I would say the easiest trick would be to not point your antenna straight across the stage, but tend to point it out more towards the audience. And that would probably be a fix. If this is something that's going to happen every single time you do it, I'd seriously look at adding a second pair of antennas for your 100-foot thing and zone it. So I hope that helps. From Edward. My buddy Anthony in Sacramento sent this one. Is there any way to use existing Cat 6 for antennas? Well, you've sort of stumped me on that because I've never actually tried it. Here's what I'll tell you about that. Cat 6 has a frequency response limit that's about as far up as used in UHF wireless mics. I don't remember, 600 megahertz or something for Cat 6 is the high frequency extension of it, where your regular coaxes will work. I mean, they lose a lot of signal, but they'll work up to gigahertz, multiple gigahertz. So you're right at the limit of what you can do. The second thing is that if you think about it, coax wire is meant to move an electromagnetic wave, where Cat 6 wire is meant to move an electrical signal. And what that means is, because coax is round and the thing is in the center and it's shielded all the way around it, it's going to keep that from leaking out. Cat 6 generally isn't shielded. It's twisted pair. It's unevenly twisted pair. The other thing that's going to be bad is the impedance is going to be all wrong. So instead of having 50 ohm coax, you're going to have, I don't know what Cat 6 is, 100, 110 ohm stuff. So you'd have to use, Balun transformers on both ends of it. So if the question is, all I've got is Cat 6, I'm stuck on a desert island and I can't do anything else, it might work. I certainly wouldn't set up a system to do it that way. It works the other way around, though. You can use coax to send like Ethernet through. You get what's called MoCA adapters. What is that? Multimedia over coax, MOCA, and you can do that. You could send Ethernet over coax most of the time, but going the other way around, I wouldn't advise it. But I have to tell you, I haven't actually measured it, so I'm sort of guessing based on other stuff that I know. I wouldn't suggest it. You really should use coax. It's just the right thing. Cat 6, like I said, Cat 6 is for electrical impulses, but electromagnetic waves, that's what coax was invented for. So I would discourage it. But like I said, stuck on a desert island, it might work. I just wouldn't want to leave it that way. Antenna placement for house of worship. or any place else, I guess. Well, it depends on your antenna. Do you have a directional antenna or do you have an omnidirectional antenna? So let's cover that first. And the easiest way to do that would be to picture a football field. Omnidirectional antennas work best when they're in the middle of everything. So if I wanted to cover a football field, just because I got yard markers easier to do, an omnidirectional antenna would be best on the 50-yard line. If I need to put my antenna at the back of the building or the side of the building or something like that, or in the end zone, I would use a directional antenna, and then I would shoot it. I would point it towards across the football field. That will cover the football field. If I put an omnidirectional microphone under the goalpost, I'm going to cover out into the football field. Now, directional antennas, basically you take that round pattern, you cut it in half, and you put the back half on the front half. So you've got two halves going one way and no halves going the back way. So directional antennas appear to reach farther because of that, because they're directional. But so if I put my omni antenna under the goalpost, yes, I'm going to cover out into the football field, but I'm also going to cover backwards into the parking lot. And I probably don't want what's in the parking lot, right? Because that's extra noise. So omnidirectional antennas almost always increase your noise floor. They're finding interference in 360 degrees, where a directional antenna, most of them are 120 degrees, just pick up in one direction. So they're going to ignore the noise for the other 2/3 of the pattern. Again, it's like cardioid microphones and omnidirectional microphones. You know, if you're just trying to pick up a singer, you point a directional microphone at them, and that's pretty much what you get. If you want to get the singer and everybody out in the audience at the same time, you can use an omnidirectional microphone, and it picks up in all directions. So that's the first thing. You got to determine whether you have a directional or an omnidirectional antenna. Okay, so most of the time, 99 times out of 100, 999 times out of 1,000, I would use directional antennas. Omnis I almost only ever use outdoors. I mean, they're exactly the right tool for a certain job, but most of the time, it's not the right tool. So a directional antenna is usually going to be beneficial indoors. Okay, so where do I put it? Well, I can put it on the stage. I can shoot it across the stage. I mean, generally speaking, you'd like your antenna to be closer to your transmitters than farther away from your transmitters, okay? But like we talked about on the first slide, not too close. You can get too close. So I can put my antenna up on the stage. I could put it in a wing and shoot it across the stage. That will cover the stage nicely. It will ignore the audience somewhat. I can put the antenna on the back wall of my room, and I can point it towards the stage. And I will cover everything going forward. You know, if I'm shooting across a long distance like that and there's interference, you know, in my audience and, you know, in the pews of a house of worship, and there will be from T-Mobile cell phones, you're going to be picking more of that up. So that's going to increase that problem. But there's ways to deal with that with the bandpass interference filters. Now, if I put it in the center of a back wall shooting towards the stage, I'm going to be a little bit weak in the back wall corners. That can be a good thing or a bad thing. If you're never going to be there, it's not going to matter, right? And also, if you've got something, there's one room I used to do where they had like the electrical closet for the whole big industrial building was in there. It was a separate little tiny room, but it was back in a corner like that. And it generated a bunch of RF interference. So having that sort of in the dead area of the antenna was a benefit in that case. Now, how dead is it? Well, it depends how far away you are from it. If you're 20 feet away from it, it's still going to mostly pick you up, probably. If you're 50 feet or 100 feet away from it, back in those corners, in other words, if it's a really big building, then those corners are going to be dead. But if your room is, say your room is 50 feet wide and 100 feet long, and I put it on the back wall and shoot it across the 100 feet to the stage, that's fine. I'm still going to have reasonable pickup in those back corners. So that would be, it just depends what you're trying to do. The thing you do want to watch out for, and it just says antenna placement, so I'm talking about wireless microphones. What you don't want to do is point your wireless microphone receiver antennas at your in-ear monitor transmit antennas. In other words, the very worst thing you could do would be to put your wireless mic antennas on one side of the stage and your in-ear at the other and point them at each other, right? So it becomes an awful lot like feedback, microphone to a speaker. You don't want to point the microphone at the speaker. You want it, behind the speaker or pointed away from the speaker to avoid feedback. And you're going to get a similar kind of thing in that situation. So if you're using IEMs and wireless microphones at the same time, they either should be at 90 degrees to each other or both on the same wall, pointed in the same direction. You just don't want to point them at each other. So that's the simple thing. I mean, there can be really complicated things if your room's really complicated, and that's going to be a one-on-one situation. But just generally speaking, I would recommend that, you use directional antennas, you point them at your transmitters, as best you can. And that's kind of what you can do. If that won't do it, then you have to zone and use multiple antennas, which is a very more complex. There's a lot more stuff to do, but that works fine too. It's just more costly and usually can be avoided for a typical house of worship. Shouldn't be necessary unless it's really, really big. If you've got 2,000 or 3,000 or 4,000 people in a room, we got to talk. That's going to be altogether different than if you've got 200 or 400 or 800 in a room. That's a different thing. But other than that, just use directional antennas and point them at your transmitters is the simple solution. Okay, can I connect multiple channel distribution systems together with one set of antennas? Yes. Although it's probably better to just connect second distros. You can cascade 2 distros together. However, you do give up one output. So in our case, our distro 4s, let's take as an example. They actually have 5 outputs. Cascade is a active, isolated, buffered output. It's really just channel 5. So if you needed to use 2 of those and you needed to use 10 receivers, you can split the antennas coming in on the front end. So you just use our passive 2x1 splitters. You plug the antenna, and passive 2x1 splitters can either take 1 input and split it to 2 outputs, or can take 2 inputs and combine it to 1 output. It works in either direction. Okay. In this case, you would plug the antennas, the A and the B, so it's going to take 2 of these. You would plug them to the one side of the 2x1 splitter, and then you would take, so let's just look at channel A for a minute, channel A antenna. So channel A antenna is going to plug into the one side of the splitter, and then the 2 outputs are going to plug to the inputs of the 2 individual distros, right? So that's how you do it. So if you needed to get all 10 outputs, you could do it that way. If you didn't need 10 outputs, if you only needed 9 or fewer outputs, you'd probably be better off to just cascade the distro in the normal manner. But sometimes people need all 10, and that's how you do that. So it's pretty simple. Occasionally we get conflicting results between coordination softwares. Well, I imagine there's some tiny differences between the softwares themselves and the way they calculate things, but that's going to be, that's going to be pretty much the same. So That I can't speak to without knowing precisely which softwares and how they're written, which frankly is above my pay grade. But part of the reason that you get different answers, coordination softwares, first of all, you should always be using them. I think anymore, it's just guessing is just not going to get it done. So you need one of these programs to very carefully predict the frequencies that you should be using. The problem with them is the how you set them up and how good the data is that you're feeding them. Okay, if you're using a receiver that so if you're using most of the wireless mics that don't cost a few $1,000s are in blocks. You know, you're going to get 60 megahertz. You're going to get from 470 to 530 or something like that. If you use that receiver to plug into your computer and feed it, that's all it can measure. It can only measure between whatever frequencies it can pick up. So it's ignoring all the things that are outside that bandwidth, right? And so it doesn't know that there's other things interfering with it. You're not telling the software everything it needs to know. We usually recommend that you scan about 50 megahertz above and below whatever frequencies you plan to tune to. So if you plan to tune across the whole band from 470 to 608, you know, then you better be measuring down to 420 or 430 on the bottom and 650 on the top, so that you're finding all the other interferers, because that's what these programs do. They're looking at all the radios that can interact with each other, and then they predict the best frequencies going forward. It also depends. I'll give you another thing to watch for, because a lot of people are trying to use microphones and in-ear monitors. When you do that, you're really best to set up exclusion zones. In other words, look at the microphones as one setting and then look at the ears as a second. Because otherwise, what these softwares will do is they just see them as, pardon me, if you had 10 microphones and 10 ears, the software will just see that as 20 radios, and it'll look at making 20 radios together. However, you get your ears and your mics are better when they're split in groups. So it's better to group your mics together and group your ears together. And so when you run that in a coordination software, you want to exclude, you know, when you're running your mics, you want to exclude your IEM frequencies, and likewise backwards. When you're doing in-ears, you want to exclude your mic frequencies, and that's gonna give you a better result. The other thing I would say about coordination software is not exactly part of this question, but I would always ask it for more microphones than you need. So, for example, if you need 10 microphones, I would ask it for 12. You always want to have your backup frequencies ready to go, because inevitably somebody's going to walk in your door with something you didn't plan on and screw up your whole thing. So I would have a couple of frequencies already set and ready to go. You know, with that. The other thing you can do is, so if you need 10 microphones and you ask it for 12 and it can give you 12, that's fine. Just for giggles, ask it for 16, ask it for 20. So if you only need 10 and it can give you 20, then you know you're sitting in a pretty low interference zone, and that your system is going to be a whole lot more stable. Sometimes you ask it for 10 and it can only give you 9 or 6. You know, that's a tougher problem. So you know you're in a really high interference area. So by knowing how many extra channels it can give you that you don't need, but it just kind of gives you a better overview of what you're sitting in, and you know how difficult your job might be or not. Using a 4-zone, what would be the best remote antenna approach? Well, depends what you're doing. So usually the best way to set up antennas is to have one A and one B in each room, assuming you have separate rooms, right? So if we've got 4 different buildings, we put an A and a B in each room, and if they're relatively small buildings, by relatively small, like if they'd hold an audience of 800 or 1,000, then you're probably best to use, like a diversity fin or our diversity architectural in that room. So you're just mounting one, that's your 2 antennas. If you're trying to cover a really big area, so if you're trying to cover a convention center hall that'll hold 6,000 people or something, then you want to split your antennas up. So I'll show you, I've got a little picture here. When you're using multiple zones, your transmitter needs to be able to find one A antenna and one B antenna, but they don't have to be in the same zone. So if we look at this, if this were a really big building, if this building were, 600 feet long or something like that, and we lined up our antennas roughly like this, if we look at the left side, well, we got one A and one B, and the yellow, and these balloons are not to scale. Obviously, it would cover way more than this, but just to show you. So the yellow circle all the way to the left, that would be the zone from your 1A and your 1B. But also, if you look at the top, you could be in a place where your transmitter might hit 1A and 2B, right? So in a room where you, in this case, splitting your antennas up would be beneficial, right? So there's one kind of common misunderstanding that people have when they try to cover a fairly large area. They'll have 2 whips or 2 paddles or something like that, and they'll say, well, this paddle is going to cover, this 2/3 of the room, and this one's going to cover this 2/3 of the room, and then they overlap in the middle. Well, only where they overlap in the middle are you going to have diversity. You need to use your pair of antennas to cover one area, right? So they're not each covering half of the room. If they do, where they do that, you don't have diversity. So your 2 antennas really should be, 6 feet apart. You don't want to spread them 50 feet apart in most cases, because you'll lose diversity. I mean, it could work, but it's not really recommended, because inevitably you'll step in a spot and then it won't be able to switch to a B antenna. So this is, if you have a single room, then you want to split your antennas AB, 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 and alternate them. If they're separate rooms, so if it's a hotel ballroom, for example, where it could be a big room, but it also could be divided, again, I probably wouldn't use single antennas like this, because they're more difficult to install. I probably would use like our diversity architecturals and put one in each dividable space. When the space opens up, it's fine, because you can adjust for all that in the 4 zone. This is a good question. When is less transmit power appropriate, and how do you determine the correct amount in a multi-source system? Okay, so the lowest power you can use is always the best, but it has to work, right? So if we're back in that case, the first one where I might be 10 feet away from my antenna, but I might be 100 feet from my antenna, what you need to do is go out 100 feet, turn your transmitter on, and adjust your power so that it's working. And 100 feet's not a big distance, so probably low power is going to work in almost all cases for that. But it may be that, back in that same example where people are really close on a stage, but you might have one guy that wanders all the way out. Well, it might work that everybody that's on stage turn their power to the lowest thing, and then you might need to turn that one guy that's going to run out into the audience, you might need to turn his power up. They don't have to all be the same. But the more you can turn any of them down, the less they're going to interfere with each other. So in that case where you have to turn one up so the guy can get really, what if he had to go 200 feet away or 300 feet away? Well, in that case, his power is probably going to have to go up compared to all the ones that are going to stay on stage. However, when he gets on stage, he is going to interfere more with those other microphones than the rest of the microphones are going to hear with each other. So, you can optimize for a single situation. So what if I make it good for this, I make it less good for that, and that's just something you're going to have to deal with. But we always want to use the lowest amount of power that's possible, because it creates the least amount of interference, and that's the thing that we have to worry about. So same way, just take your transmitter to the farthest and or most difficult spot you think you're ever going to be in, and adjust the power for that, and then use the smallest amount of power that works at that distance, and then that's where you're going to be. Can interference cause a drop in signal strength, or is it always transmitter to receiver? Yeah, it's always transmitter to receiver, and it might be one exception in a million. So what's going to happen is interference is causing, so you got a signal and you've got interference. If the interference comes up, the signal is going to stay the same, and it diminishes with distance, but it's going to stay whatever it's going to be. If your interference is coming up and down, then we're losing that dynamic range in the middle. That's what's causing your dropout, not your loss of signal strength, until you get really, really, really far away. If you're going to get 600 feet away, yeah, you've lost the signal. But if we're talking at 50 feet or 100 feet, and you get closer to an interferer. So in other words, if you set your handheld right down next to your computer or something, you're probably going to pick up interference from your computer. So the interference is going to come up, but the level of your transmission isn't going to change because of interference, but your dynamic range. So the thing that knocks you off the air is going to get worse, but it's not the drop in signal. It's the loss of dynamic range. How do you suggest approaching coordinations near military installations where RF activity is not necessarily constant? I'm always reminded that scene in The Wizard of Oz where the wizard is, given the scarecrow. He goes, "It's not that they have brains, but they have what you don't have. They have a diploma. What they have that you don't have is F-16s. So you can't win. They're going to do whatever they're going to do, and they're going to turn it on whenever they need to." I will share a story, the personal story, that's just one of the weirdest things that I've ever seen. I lived about 4 miles from Magoo Naval Air Station in Southern California. It's in Malibu, and I lived in a townhouse complex. And one day, all of our garage doors, 60 houses in here, just randomly started opening and closing and opening for about 3 hours. And our clicker, our switches stopped working. If your door went up, you couldn't close it with your clicker. This went on for 3 days. Just randomly, doors would start opening and closing a bunch at a time, and then it would take off a few hours, and then it would come back. And at the end of 3 days, it just went away, never came back, and everybody's clicker started working again. Now, I don't know for sure, but I got to guess they were testing something. And if they need to test it, they're going to turn it on. They don't have any rules. They can do whatever they deem necessary, and there's not much you can do about it. But the thing about anything is that if you're setting up a wireless mic system and you go in and scan at 3 o'clock on Wednesday afternoon, you're going to find out what's there at 3 o'clock on Wednesday afternoon, and that might not be the same thing as Sunday morning at 10 a.m. I've had that happen too. It doesn't interfere with wireless mics as much as it used to, but AM radio stations can change their antenna patterns in the evening, for example. But other things happen. People turn on stuff or people turn off stuff. You may have some kind of industrial machinery that's making RF, and they turn it off on the weekends when they're not there. So there's there's really no way except to be scanning while it's happening. Most of the time, that's not necessary, but things can sneak up on you, and you're just stuck. So you make as many measurements as you can. You average them out, and you hope you don't get caught. Because still, if somebody turns on something, it's the same way. I've seen it happen a number of times at churches in particular. We set up a system, we measure it, we balance it, we do the frequency coordination, we get everything good as gold, and then they have some traveling musicians come in, and they've got transmitters on their guitars we didn't know about, and all of a sudden everything falls apart. There's just no way to know ahead of time. I mean, you can ask, but you ask them what wireless microphones they're using, they forget to tell you they're using transmitters with their guitars. They don't consider those microphones. And it's like, okay, I get it, but they're radios, and so they interfere. So, there's not a way to guarantee this. Like I said, make as many measurements as you can, average them out, and hope for the best. Okay, Adam, do we have a couple more? We got time for a couple more.
Yeah, we got 3 really good ones. So I'll start.
3 really good ones. Okay.
3 really good ones, I think. I'll start in order of importance and popularity, perhaps. So the first one that I think is worth discussing is, what interference do LED screens cause, and what can RF venue do to help?
Okay. So any LED lighting, whether it's stage lighting, so LED video, that can be a television set, a video wall, all those kind of things. What happens, it's not the LEDs that cause the problem, it's the power supplies. They use what's called switch mode power supplies, which take the power and take the 60 cycles out of the wall and shoot it up to something extremely high, like, hundreds of kilohertz or something, and so it becomes a little radio transmitter, and so it's the power supplies. The good news is that's getting better as people are understanding that's what's happening. A lot of manufacturers are now putting filtering and stuff in their sets. So if it's just a video monitor, if it's like a TV set, you've got a 50-inch TV set hung up on a wall, the power supply is going to be internal. And a lot of the new video walls are like multiple boxes you plug together. They've got internal power supplies. If you've got external power supplies, like if you've got 100-foot video walls, 50-foot video walls, those tend to have external power supplies. And what you need to do is shield those. There's a thing that they use in theater and production called black wrap, which it's tinfoil, but it's black. And you can take that and you just tear it off a roll. It's like Reynolds wrap. Tear it off on a roll. You can cover your power supplies with that. That'll knock down the interference some. The other thing you can do is you can use bandpass filters. And our bandpass filters, so you've got a number, a bottom number and a top number. So you might have 470 to 560. That'll block. So LED interference tends to be from about 500 and lower, and it's much worse the lower you go. So there's a little bit at 500, there's more at 400, there's a lot more at 300, that kind of thing. So that's going to block that much of the signal from getting back into your system. So that's the sort of active thing you could do. Now, if your mics can tune up higher, if you have this kind of problem and your mics are all up at 580, then use the bandpass filter that's 530 to whatever, or 560 to whatever, because that's going to block it even more. But the bandpass filters would be a big help.
Awesome. Yeah, that's been a very hot topic lately, because obviously those are getting much more popular. So
everybody's got them.
Yep, absolutely. And bandpass filters, easy upgrade to any wireless mic system. So here's another one that comes up a lot, Don. What's the coverage difference between the DFIN and the D-ARC?
Okay, so the coverage of antennas, any antenna, has to do with the pattern, right? So if we start with an omnidirectional, just a whip antenna, everybody knows a whip. Okay, it's 360 degrees horizontal. It's actually donut shaped. It's dead on the top and the bottom. It's not a ball, but it's a donut. So in 300, it picks up equally in all directions. So whatever it picks up 100 feet to the north, it picks up 100 feet to the south, and 100 feet to the east, and 100 feet to the west. As you make an antenna directional, it's just like using a megaphone. I'm focusing the sound more to go out straight and not so much to go sideways out of my mouth. So the tighter I do that, the more concentrated the energy is, right? So the simple, a D-fin or almost all paddles are 120 degrees of horizontal. So that other 270, it has a pattern that's roughly 1/3 of that circle, but it's going forward. So you take the other 2/3 of that power and you add it into that third that's going forward. So it's got more reach forward, but because you've given it up from the back and the sides. So in the case of the D-arc and the D-fin, the D-architectural antenna is a little wider. It's like 140 degrees or so wide, where the diversity fin's 120. So because the diversity fin is a little more narrow, then its apparent reach is a little longer. I would say, if you think of it as maybe 20%, right? So whatever you have, if you were trying to reach out, 300 feet with a diversity fin, and you had a diversity architectural, take 60 or so off it, you'd be, 240-ish, something like that. It depends on, the exact number depends on every single room, but so normally I wouldn't worry about a D-fin at like 300 feet, and I wouldn't worry about a D-architectural at 200 feet. I would just plug them in and go. I don't think you have to do a whole lot of calculation. I think that's going to be pretty safe for most people.
Great, thanks, Don. That's been a very popular question lately. Here's a really good one. We seem to have issues with multipath cancellation with IEMs. There's no interference on the receiver with squelch off, but we get dropouts in very specific locations. Any ways to deal with that?
Well, you're gonna get hot spots and cold spots on your stage. So with IEMs, we're almost always talking about single channel radio. So we don't have diversity. So if you step in a hot spot, your second antenna can't be not in a hot spot. That's not going to happen. See, what they didn't say is what antenna they're using, right? So you want to use a helical antenna because it's spinning its pattern. It's not a straight pattern. So a whip or a paddle it's receiving. So it's receiving horizontally. And as you twist your belt pack, you're not shooting straight into that. You're glancing off it. So the level that your antenna can pick up is always fading in and fading out, right? With a helical antenna, that doesn't happen. So you're going to eliminate that much. Now, if the problem is you're trying to use, in-ear monitors in the boys' locker room where you've got so much metal all over the place, that's just a hard thing to do. If you're in a Quonset hut, if you're in a tin building, if you're in a rodeo arena or something, it's going to be hard. And sometimes the answer is you're going to need to buy a whole lot more expensive in-ear monitors. That may be the only thing that works for you. But basically, make sure that you're using a helical antenna. Make sure that your belt packs are not in your pockets, because you're killing your antenna if it gets really close to your skin. So when you put it in your pocket and the antenna is only the thickness away from the cloth inside your pocket to your skin, you're killing half of the power of of the receiver. So even just the distance, when you put it on your belt and it's a ½ inch away from your skin, that's a huge, 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 huge advantage. It doesn't seem like much. You go, it's a ½ inch. Yeah, but it's, it's 20 times better for power. So that would be, yeah, that's my best suggestion. I don't know what antenna you're using. Use a helical. And if that's not working, because then you can try, moving your antenna to different places, because then your hotspots are going to move. Your hotspots and your cold spots are going to change.
Brian said he was using the CP beam, Don, so he is using a helical, and he also said that he has ground-supported truss rod, so there may be some interaction there.
What, it has a ground-supported what?
He said he had ground-supported truss roof. Sorry, not rod, roof.
Oh. It's a metal roof? Yeah, well, you just have a really hard room. And the answer is, use lower power, use a frequency coordination program to make sure you've got the absolute best channels you can get. It's probably not one thing that's your problem. You got a little bit of this and a little bit of that and a little bit of that and a little bit of that. And if we can make each one of those just a tiny bit better, that may solve it. I would also try, repositioning your antenna. That's probably it. But there's going to be a point which, nothing but $5,000 a piece monitors are going to work. Some rooms are like that.
Makes sense. Thanks, Don. I think we have time for one more here. It's a fairly cool question. I think we had a couple of customers do this very thing, but maybe you can sort it out for us. Is it possible to loop the signal from an RX antenna distro directly to a TX antenna distro in order to re-amplify the signal? The use case here is sending audio to a satellite P where running a cable is not possible. So one of our customers did this. They were sending point and receive, right? They had, because they couldn't run cables at the Mercedes-Benz bike competition, so they had diversity fin shooting, CP beam shooting to a diversity fin to get that audio into a PA that way. I think that's the question. I'm not sure.
Well, you can do point to point. I'm sorry. I'm gonna have to ask you to read that again. While you were reading me that, I just got so I'm in California. I just got an earthquake alert from the earthquake system.
All right, I'll read it again slowly.
So just one more time.
All right, as long as it's not earthquaking where you are, I'll read this. Is it possible to loop the signal from an RX antenna distro directly to a TX antenna distro in order to re-amplify the signal? The use case here is sending audio to a satellite PA where running a physical cable is not possible. And to follow that up, Don, said, yes,
so they want to.
Distance is 1,000 feet. So. That's a lot of distance you got there to go from antenna to antenna.
Yeah, so they want to take a combined signal from a distro, point it to another distro, right?
Right.
Man, that would be really, really complicated.
Well, you'd be using an IEM and a mic, right? So you have the IEM feeding the antenna, system, sending the signal, right?
Well, the IEM's not going into the distro. The distro is receiving. So right, I'm a little confused. So if what you're trying to do is to have, why would you split distros? I think what they're trying to do is just extend IEM transmitters. And yeah, really the right way to do that would be to do it using fiber optic. That would be a case. That would be a case for using something like our optics system, where you can. Yeah, that would be the right way to do that. I mean, what they're trying to do is, re-amplify the signal, which is possible. Those are really expensive kind of amplifiers. You're going to degrade the signal a lot. It's just not the right way to do it. It might be able to pull it off, but it's not the right way to do it. The right way to do it would be just to send the signal over fiber to wherever you need it and then grab it there.
Gotcha. Yeah, that makes sense. But if you do want to take a look at some of the customers, there's on our case study page, we have a customer who did that because they could not run cables, and they sent and received to a PA locally, and they were able to get in tricky spots with all the bikes going through and people and crowds and everything else. They just could not run cables. So he says here, yes, we're trying to use an IEM system as the receiver. We cannot run cable point to point. So they do have a send and receive sort of situation, which is what the guys from I forget the name of the company, but it's on our site. If you go to case studies, you can see it's the Mercedes-Benz cycling tour. They did that.
Yeah, there's kind of a limit to what you can do easily. Although, with fiber optic, I mean, you can split that to 5 kilometers. So I've done that. I used to work with the guys that did the Rose Parade, New Year's Day in Pasadena. And we had to cover, I don't know, half a mile down Colorado Boulevard. And there's just no way to run coax that far. So you got to do it with fiber.
Yep. So check out our Optic Series 3 fiber system, and hopefully you want to hire some angry guys to pull the cable for you.
Yep.
And that's all the questions. So if there's, I think we've extended our time a little bit. We really appreciate your time on this call, and hopefully you'll join us in the next one. We're going to be doing this monthly, where we answer all your questions, and hopefully get some questions beforehand so we can give you those and then answer questions live as well. So I hope this was effective for everybody. And it's certainly, if you have any questions you want to follow up, you can email me or Don, just our first names at rfnu.com, and we're happy to help in any way.
All right. Well, thanks for joining us, guys, and we'll see you next month for the same thing.
All right, guys, have a good one. Take care.